Then about data warehouse schemas. So we can think of a data warehouse schema such as blueprint or an architecture, how a data will stored and managed. So the data warehouse schema isn't the data itself, but the organization, how the data is stored and how it is related to the other data within the data warehouse. So in the past, the data warehouse schema were often strictly enforced across enterprises, but in model implementation, where storage is increased, inexpensive, so the schema may become very less constraints. Despite of this losing or sometimes the total abundance of data warehouse schema, knowledge of this functional schemas design can be important to both maintaining the legacy resources and to creating modern data warehouse design that we have learned for the past. So the basic components of all the data warehouse schema are this fact and dimension tables. The first combination of these two centralized element composed almost the entirety of all the data warehouse design schemas. So the fact table aggregates the metrics, measurements, or facts about the business table. For example, the fact table are connected to dimensional table to form a schema attribute architecture representing how the data is related with the data warehouse. The fact tables stores the primary key of the dimensional table as a foreign key within the fact table. Then what is this dimension table is a non-denormalized table used to store the data attributes or dimensions. As we have told that the primary key of the dimensions table is stored as the foreign key in the fact table. So the dimension table are not joined together. Instead, they are joined via associated to a centralized fact table. So there are mainly we are having three types of schema used in the data warehouses. They are star schema, snowflake schema, and galaxy schema. So each of these data warehouse schema are unique design constraint and describes the different organization structure, how the data is stored, and how it is related to the other data within the data warehouse. So, what is this data schema, this star schema in data warehouses? This is an historical one of the most straightforward design. This schema follows all the distinguished design pattern, such as only permitting one central table and handfully of single dimensional table joined to the tables. So in this diagram, so the design constraints a star schema can be reassembled a star with one centralized table and five dimensional tables can be joined. So the star schema is known to create a denormalized dimension tables. So the database structuring strategy that organize the table is to introduce redundancy for improved performance. So this denormalized intend to introduce redundancy in additional dimension so that how longer it improves the query performance. So the main characteristics of this star schema is this star schema creates denormalized data that enables quick query responses as the primary key in the decision table joined in the fact table as an product key. As we have seen already, this customer, product, time, company are going to be the fact table, sorry, fact table, and this sales is going to be the dimensional as the dimensional table here. Sorry, this is dimensional table, and here this is going to be the fact table. So all the primary key of this thing is included here. So the primary key in the dimension table is joined to the fact table by the foreign key. Each dimension table is the star schema mapped to the one dimensional tables. So this dimension tables is within the star schema or not to be connected directly. So the star schema creating denormalized dimensional table here. Then what is this flow flag schema is? It is an data warehouse schema that encompass a logic of arranging these dimensional tables. So this data warehouse schema is built from star schema by adding additional subdimensional tables that related to an first order dimensional table joining the fact table. Just like the relationship between the foreign key in the fact table and the primary key in the dimensional table. This snowflakes schema approaches primary key in the subdecision table with relates the foreign key within the higher order dimensions. So this snowflake schema creates normalized decision tables. So the database structure strategy that organizational table is reducing redundancy. The purpose of normalization is to limit any redundant data to reduce overhead. So this is going to be the star schema. So the snowflake schema is when I'm going to have the additional tables like location, table, country, then this variant, which makes this Dataverse schema builds this star schema by adding subdimensional tables. So the characteristics of this snowflake schema is to permit the dimensional table to join to another dimensional table. So the snowflake schema are not to have one fact table only. Then here it creates a normalized dimension table. So the normalized schema reduced required disk space for running and managing its data warehouse. So the snowflake schema offers an easy way to implement this dimension. Then about this galaxy schema. So the galaxy schema, galaxy data warehouse schema is known as the fact cons- um, the fast constellation schema, which act as the next level of inheritance of a data warehouse schema. It's not like the star schema or the snowflake schema here. So the galaxy schema has multi users uses multi fact tables connected with the shared normalized decision tables. So the galaxy schema can be thought as an star schema interlinked and completely normalized, avoiding any kind of redundancy or inconsistent data. So the characteristic of this galaxy schema is the galaxy schema is a multi-dimensional, acting as a strong design consideration of complex database system. So this galaxy schema reduces redundancy to nearly zero redundancy as a result of this normalization. Then this galaxy schema is known for high data quality, accuracy, and leads to effective reporting and analysis. So here we will have different data fact tables with connection to the dimensional tables here. So to understand the Varro schema and its various types at conceptual level, so we should remember that the data Varro schema is going to be the blueprint of how the data will be stored and it is going to be managed. So it includes the definition of terms, relationships, arrangement of those terms, and these relationships. So this three-star galaxy and snowflakes are common type of data barrow schema that varies arrangement and design of data relationships. So the star schema is simply the data barrow schema contain just one center table handfully of a single dimensional table joined one. Whereas this snowflake schema built on the star schema by adding sub dimensional table which eliminates the redundancy and reduce the overhead cost. But galaxy schema uses multiple fact table which the star and snowflakes will be using only one fact table. Here in galaxy schema it will be using multiple fact table which makes it like an interlinked star schema. So this is nearly eliminating the redundancy and it is the idea of complex database system. So this galaxy schema is for representing multi-dimensional model. It is a collection of multiple fact tables having some common dimension tables. It can be viewed as an the collection of several star schemas and hence it is called as the galaxy schema. Uh, it is the one of the most widely used schema of data warehouse design and it is more complex than star and snowflake schemas. Um, when we are going to compare the key difference between the star snowflakes, and galaxy schema. See, if you are going to consider with the elements, so it in star schema it has single fact table connected to a multiple dimensional table. In snowfall, single flags table, but we will be having subdivision tables also, dimension table also. But in galaxy schema, we will be having multiple flags table connected to multiple dimensional table. When you are going to consider with normalization, star schema is denormalized one, snowflake schema is a normalized one, and galaxy schema is also a normalized one. So the number of dimension is multiple dimensional table mapped to a single fact table. In snowflakes, multiple dimensional table to multiple dimension tables. In galaxy schema, again, multiple dimensional tables are mapped to multiple fact tables. Then data redundancy in star it is very high, in snowflakes and galaxy it is low. Performance wise, if you are going to compare star, few foreign key result increased performance. For snowflakes, decreases the performance as there are high number of foreign keys are used. In galaxy schema, again the performance is lower than the star and the snowflakes as we are going to use complex data aggregation. Uh, Comparing the complexity, star is simple design, whereas snowflakes and galaxy are more complex one. Then storage use is like star sequence has high disk space due to data redundancy, whereas snowflakes and galaxy uses low disk space. Design elimination is like limitations or one table only, no subtable in star schema. Snowflakes schema, we are having only one flags table, but we are allowed to have multiple subdimensions. When compared to the galaxy schema, here we are having multiple flags table and the first level dimension also permitted in the galaxy schema. So this is going to be the comparison between the stars, snowflakes, and galaxy schemas.